Hi algebra students, please pull out your rotations notes packet. We're going to talk about rotations today, which is talking about turning a figure around a fixed point. That's the definition right there. There are two directions that we can turn the objects. We can turn them clockwise, which is in the direction of the clock, and we can turn them counterclockwise, which is in the opposite direction. We need to know the two D's of rotations. We're going to discuss degree, which talks about how far we are rotating. And we need to talk about direction, which means clockwise or counterclockwise. Looking at the next question, we want to know, after a rotation has been performed, is the image going to be similar or congruent? The image is going to be congruent because it's going to be the same size and the same shape. Down here we have two examples of common English letters. Starting with the T, we can rotate it 90 degrees clockwise in this direction. We can rotate it 180 clockwise. We can rotate it 270 degrees clockwise. But we can also talk about counterclockwise. So looking at that, we could do 90 degrees counterclockwise, 180 degrees counterclockwise, and 270. Counterclockwise. It helps if you think of a clock when you're doing this. So if I rotate this H 90 degrees clockwise, it's going to look like it's on its side. If I do it again, it's going to look like it's straight up and down because this has vertical and horizontal symmetry, or just vertical, pardon me. And then another turn, we're going to look at it on its side again and then back. The other way you can look at it is I could get to the same picture of it by doing 180 in either direction. If we look at example 1, we're looking at triangle ABC labeled on our graph. We want to rotate the triangle 90 degrees counterclockwise, and we're going to label it. So we're going to write the new ordered pairs underneath. So this is going to be the image of A, the image of B, image of C. And so the rule here is if we turn it 90 degrees counterclockwise, we're starting with an original ordered pair for A at 1, 4. Counterclockwise 90 degrees means we're going to end up in the second quadrant over here. So the image of A after a rotation of 90 degrees counterclockwise would end up at the ordered pair -4, 1. Over to B, here's my original point. It's at the ordered pair of 5, 2. After a 90 degree counterclockwise, we're going to be at the ordered pair -2, 5. C starts at 2, 0, and a counterclockwise 90-degree rotation is going to take it to 0, 2. Now, it does look like I took this and I rotated it 90 degrees counterclockwise. There is a rule, so I'm going to fill these in, -2, 5, and 0, 2. The rule is for 90 degrees counterclockwise, we're going to take an ordered pair, we're going to flip the x and the y, they're going to switch spots, and we're going to take the opposite of the y coordinate. So now what we're going to do is we're going to rotate the triangle ABC 180 degrees counterclockwise. So for part B, we're going to take the original triangle ABC, which I wrote the ordered pairs in red at the top of the paper, and we're going to rotate it 180 degrees clockwise. The rule for clockwise 180 or clockwise counterclockwise 180 is to take the ordered pair and you take the opposite of the x and the opposite of the y's, but they stay in the same spot, x first, y second. So if we look at the first triangle, we've got A at 1, 4. So now A is going to be at -1, -4. So down in the third quadrant here. And we're going to mark it with 2 image marks because this is the second image we're making. B is now going to appear at -5, -2. And C is going to be at -2, 0. So we're taking this triangle originally and changing it a whole half of the clock, 180 degrees counterclockwise. The ordered pairs one more time. A is at -1, -4. B is at -5, -2. And C is at -2, 0. Now we're going to do 270 degrees counterclockwise. So the rule for 270 counterclockwise is to switch the y and the x and to take the opposite of the x. So the new ordered pair for A would be at 4, -1, B would be at 2, -5, and C would be at 0, -2. Because remember, we're looking at the original ordered pairs of A, B, and C. So that would look like this: 4, -1, 2, -5, and 0, -2. So that is us taking it and going all the way over. You can also think of it as a 180 and then another 90, or 3 90-degree counterclockwise turns. So for part 2, go ahead and look at your graph and your answers to those questions and organize the information in this table. CC stands for counterclockwise. So I've just recorded all of the ordered pairs that we found in the questions on the prior page. And the last thing you need to look at is 360 degrees. And if you think about 360 degrees, even if we're going counterclockwise, if you're starting at a point, 360 degrees winds you right back up at that point. So these would just be the original ordered pairs. A at 1, 4, B at 5, 2, and C at 2, 0. The other thing that's kind of cool to realize is a 270 degree counterclockwise turn is the same rule as 90 degrees clockwise. And 90 degrees counterclockwise is the same as 270 degrees clockwise. Now we're just going to put those rules that I had you scribble under part 1 in here in writing. So if we look at counterclockwise, 90 degrees is at opposite of y, comma, x. 180 degrees is at the opposite of x, the opposite of y. 270 degrees is y, comma, opposite of x. And 360 degrees is x, comma, y. So what's happening here is for the first one, we are flipping the x and the y and change first sign. For 180 degrees, we are changing the signs. For 270, we are flipping x and y and changing the second sign. And we don't change for 360. Okay, for part 4, we're doing what are the coordinates of 3, -2 under a 90-degree counterclockwise rotation about the origin. You're going to flip these, and you're going to take the opposite of the y. So this is going to be 2, 3. For 180 degrees, if you look at part 3, we are just taking the opposite of each of the x's and the y's. So that makes +5, -4, your ordered pair. For 3, 2 under a 90-degree clockwise rotation, you are going to switch the x and the y, and you're going to take the opposite of the old x. So this is going to be at 2, -3. For the next example, for 7, part A, we want to look at taking an ordered pair, and we're going to do 2 things. The first thing we're going to do is we're going to do a rotation of 90 degrees counterclockwise, which the rule is the opposite of y, x. And then it wants us to reflect that across the x-axis, which the rule there is x, comma, the opposite of y. So what I want you to do is I want you to write the original ordered pairs for r, s, and t. So those are my coordinates for r, s, and t. Now what I want you to do is follow the rule for a 90-degree counterclockwise rotation, following the rule. So check with mine. Those are the new ordered pairs for the image of r, the image of s, and the image of t. Now flip that over the x-axis. So check with my ordered pairs. The one thing that's happening here is the new x stays put, but the new y is the opposite. So all of these y values became positive. Now you're going to plot those on the graph. So there's my graph there. You'll notice that r came back to its original ordered pair. So for part B, we're going to take an ordered pair. We are going to reflect it over the x-axis, which means we're going to follow the rule x, comma, the opposite of y. And then we're going to rotate it 90 degrees counterclockwise. So that is going to look like the opposite of y, comma, x. So you want to write your 3 original ordered pairs underneath. So those are my original ordered pairs, r, s, and t. Now find the new ordered pairs, the image for the reflection. Check those reflection ordered pairs with mine, and then we're going to do the last ones the rotation of 90 degrees. Check with mine. 4, -4 for R, 3, -2 for S, and 1, -3 for T. And then we're going to plot those. So there is my final image. For part C, are the final images in parts A and B the same? Yes. They are similar and congruent. This is a really helpful rotation kind of summary page where it's just a reminder of the quadrants, what kind of ordered pairs are in those, remembering that we're talking about counterclockwise and giving the rules for each.